Welcome back. In the third installment of our tutorial series on microservices, we're going to take a step back from implementation to explore the fundamentals of microservices. We'll discuss what microservices are, the benefits of adopting this architecture, and compare it to a monolithic solution. Additionally, we'll address common mistakes organizations make when transitioning to a microservices architecture. Okay, without further ado, let's dive in. Let's start with the most basic architecture for a website, such as an e-commerce site implemented through a monolithic architecture. This architecture relies on a single, unified codebase that encompasses all application components, including the user interface, business logic, and database access logic. All these components share the same runtime environment. The main advantages of a monolithic architecture are its simplicity in development and ease of debugging, as everything is housed in one place. This centralization can also make the initial development straightforward. However, monolithic architecture poses significant challenges for large, complex applications. It limits the ability of multiple development teams to work independently on different features. It also struggles to scale efficiently. In today's fast-paced digital world, businesses need to be agile and scalable. To achieve this, we must consider a different architectural approach. Enter microservices. Unlike monolithic architectures, where all components are tightly coupled, microservices architecture breaks down an application into a collection of smaller, independent services. But what is a microservice? Imagine each microservice as an independent and specialized team, focusing on a particular task within the larger system. Each microservice can be developed, deployed, and scaled independently. This means that this architecture allows for greater flexibility and adaptability. Microservices communicate with each other through well-defined APIs, ensuring that each service can operate independently while still contributing to the overall functionality of the application. This architecture empowers development teams to work on different services simultaneously, using the best-suited technologies for each task, and deploy updates without affecting the entire system. Pretty cool, right? In today's competitive landscape, businesses need to adapt quickly to changing demands. And microservices enable rapid development and deployment and seamless integration with new technologies. But truthfully, another key reason for adopting a microservice architecture is scalability. Let's compare our monolithic and microservice e-commerce platforms. Vertical scaling, or scaling up, involves adding more power to existing machines. It's like upgrading your car's engine for more horsepower. We can scale a monolithic service that way, but this approach has limitations, such as a single point of failure and physical limits on upgrades. On the other hand, horizontal scaling, or scaling out, involves adding more machines to distribute the load. It's like expanding a fleet of cars to handle more passengers. And microservices architecture perfectly supports horizontal scaling by allowing each service to be scaled independently, thus enhancing flexibility and efficiency. Microservices offer a range of compelling benefits that make them an attractive choice for modern software development. First, improved scalability. With microservices, you can scale individual services independently, allowing your application to efficiently meet varying demands without over-provisioning resources. Next, enhanced fault isolation. By isolating failures to specific services, microservices prevent a single issue from bringing down the entire application, ensuring greater reliability and uptime. Microservices also enable a faster time to market. With the ability to develop, test, and deploy services independently, teams can accelerate their development cycles, embracing continuous integration and delivery. Another key advantage is technology flexibility. Microservices allow you to choose the best-suited technologies and languages for each service, fostering innovation and adaptability. Finally, better resource utilization. By scaling only the services that need it, you can optimize resource allocation and reduce operational costs, making your application more efficient and cost-effective. While microservices offer numerous benefits, there are common pitfalls to watch out for during adoption. So, what are these common pitfalls? First, over-fixating on one service per function. It's important to balance granularity. Assigning a microservice to every single function can lead to unnecessary complexity. Second, creating services that are too small. While microservices should be modular, making them excessively small can result in significant management overhead and communication delays. Third, Tightly coupling services. I've seen this one, firsthand, too many times. So, to maintain the independence and flexibility of microservices, ensure that services are loosely coupled. This allows for easier updates and scaling. Fourth, neglecting log management. A comprehensive logging strategy is crucial for monitoring and debugging. Implementing this from the start can save significant time and effort. Finally, rushing into adoption. Transitioning to microservices requires thorough planning and understanding. Rushing can lead to performance issues and integration challenges. So, please, as you transition your applications to a microservice architecture, keep in mind these common mistakes so that you can better navigate this transition and fully leverage all the benefits we discussed. Alright, this is it for today. But there's more coming. In our next tutorial, we'll dive further into the microservice architecture, going over the 5 most commonly used design patterns in a microservice architecture. We'll talk about the database per service, which we depicted in today's example. We'll present as well the API gateway pattern and the event-driven pattern. We'll then talk about the service registry and discovery, where microservices register themselves upon startup and deregister when shutting down. And we'll conclude with the circuit breaker pattern, which is critical to detect failures and prevent cascading failures in a microservices ecosystem. So, please, stay tuned and subscribe if you'd like to get notified when the next tutorial is published. Thank you, and see you next time.